everyone! I am Hardlock Man. Today, I will be showing you the Hardlock nut at work, ensuring safety in a number of places around the world. Wow, that's fast! The Hardlock nut is at work aboard the Shinkansen, one of the fastest and safest trains in the world. The train cars and rails are subjected to unimaginable vibrations and impacts. Nevertheless, the Hardlock nut every day demonstrates its intrinsic power in such a demanding application. What is that? Excuse me? How is it different from other nuts? Well, take a look at this test. This test apparatus generates the toughest vibrations in the world in compliance with National Aerospace Standards NAS 3350 and 3354. So let's use it to test how loose the Hardlock nut and other nuts become under vibrations. The nuts are marked prior to testing. So what would happen if you were on the Shinkansen in this kind of situation? Nothing has changed with the Hardlock nut. Take a look at the markings. It hasn't loosened even a little. These are the results of looseness tests. The ordinary nut flew off in 12 seconds, and the double nuts in 30. But the Hardlock nut did not loosen even the slightest, even after the maximum 30,000 test cycles and 17 minutes of vibration exposure. This is a transverse junker machine. It couples a bolt to a stationary table and vibration table and moves the vibration table at a right angle to the bolt shaft, then measures any change in tightness. Here are the test results. The vertical axis represents the load applied in the axial direction of the bolt. In short, any loosening of the threads shows up as a decrease in this axial load. As you can see, other bolts loosened and subsequently the axial load dropped almost to zero as the vibration frequency increased. However, hardly any change at all can be seen in the Hardlock nut plot. The axial load stayed constant for the most part, indicating that the nut did not loosen. These stringent tests prove that the Hardlock nut can stand up to impacts from any direction. Next, I want to show you the mechanism that produces the highest anti-loosening performance in the world. The Hardlock nut works by wedging. Wedges are used in places like the torii arches of a Shinto shrine to firmly hold two pieces together. As shown in this diagram, hammering a wedge between the nut and bolt completely fastens the two, but this is hardly practical as a product when you consider workability. So we divided the nut in two, whereby the convex nut plays the role of the wedge and the concave nut functions as the hammer. The convex nut of the Hardlock nut is fabricated as a wedge by an eccentric structure that is slightly off-center. This wedge screws in between the concave nut and the bolt to produce a powerful anti-loosening effect. In other words, the convex nut acts like a wedge because it is off-center, and the concave nut functions like a hammer as it is screwed in. The Hardlock nut began garnering worldwide attention when a research paper was submitted to a gathering of the American Society of Mechanical Engineers, held in Denver, Colorado in July 2005. The paper scientifically proved that the Hardlock nut never loosens because of its structure. When a strong impact is applied to a bolt shaft in the longitudinal direction, an ordinary bolt slowly turns in reverse. This shows the nut loosening under vibrations. With the Hardlock nut, though some movement to the left and right occurs, you can see that the nut does not turn in reverse. This is the secret behind the world's highest anti-loosening performance that keeps the nut from loosening under any size of impact. The Hardlock nut is protecting lives day and night in many inconspicuous places. Therefore, a number of quality checks are carefully repeated as part of quality management. This machine measures the dimensions of a bolt in 6 places at a time. This is a nut fastening tester. And this is a high-definition digital projector. Besides this equipment, a variety of inspections are repeated to ensure durability, workability, and fastening and removal. Moreover, once you tighten the Hardlock nut, it does not come loose, so it offers great cost advantages in that it is practically maintenance-free. So, did you understand the secret behind the high anti-loosening performance of the Hardlock nut? Now, I want to show some places around the world where the Hardlock nut is at work. The first is with railroads. The primary requirement of nuts used with railroads is that they never loosen. Loose nuts can lead to serious accidents. In Japan, the Hardlock nut is used as fasteners at stations and inside walls and other locations of the famed Shinkansen and many other lines to ensure safety. In the UK, it has been officially adopted by National Network Rail since 2003, replacing a majority of the fasteners on board train cars, along tracks, switches, and overhead wires, and at stations. It has also been adopted as a fastener for the Taiwan High-Speed Rail. It was also officially approved by Queensland Railways of Australia and has been put to use in many locations. Japan has many earthquakes. If an earthquake were to loosen nuts, there could be serious consequences. That is why the Hardlock nut is used all across the country in highways and bridges, skyscrapers, stadiums, power plants, steel mills, and earthquake-proof homes. Moreover, the Hardlock bearing nut is widely used to keep bearings from loosening on transport vehicles, including forklifts, dump trucks, and ships. We received many requests for presentations from all over the place, and many people from abroad have come to visit our factory. By talking about our experiences and failures, we hope to carry on the manufacturing spirit of Japan. This part of our factory is for freshening up. It looks like they are having fun. Last but not least, let me introduce you to our forever growing Hardlock family. This is the Hardlock rim that works as a stopper for the Hardlock nut and improves workability. This is the Hardlock bearing nut that is used with a wide range of industrial machinery to lock bearings and prevent loosening. This is the single type space lock nut. It delivers anti-loosening performance with a single nut as a means for reducing weight. This is the Hardlock set screw that revolutionized mold clamping in the automotive industry. It was developed by thinking about the Hardlock nut from the opposite direction. Nothing is 100% perfect, but Hardlock industry is always asking questions and thinking up ways to improve things when developing new products. What started in Japan has spread around the world. The products of Hardlock industry are fast at work in places you do not see within the foundations of society. Since our founding, everyone at Hardlock industry, no matter what process they are involved with, has been forever passionate about safety in order to ensure world-class quality and make products that are guaranteed safe under any kind of environment. Safety is power, so please continue to use the Hardlock nut.